Hi, everyone. Today I will tell you about isomerism. But before start, let's know a little about isomerism. Isomerism is phenomenon by which organic compound can exist in different forms with same molecular formula, but different structural formula. And it classified into two types, which are structural isomerism and stereoisomerism. Indeed, there are four types of structural isomerism, which are chain, positional, functional, metamerism, while stereoisomerism have two types, which are configurational and conformational. Configurational divided into two types, which are optical and geometrical. So, in this video I will explain the first part, which is structural isomerism, while stereoisomerism I will explain in next video. Let's start with first type of structural isomerism, which is chain. Chain happen when carbon atoms are linked together in different ways from compound to compound. How? Let's take this example. If the organic compound has this molecular formula C5H12. Okay. As we know that C5H12 means pentane. So pentane is chain consists of 5 carbon atoms and 12 hydrogen. Now according to the meaning of chain, we can form several compound from C5H12 other than pentane, like 2-methylbutane and 2,2-dimethylpropane. So all these compounds have the same molecular formula, which is C5H12, but different structural. Now, let's move on to second type, which is positional. Positional happens when the functional groups are in different positions on the same carbon chain. For example, 1-butanol. As you can see here, alcohol group present in position number 1. So the isomerism of this is 2-butanol. And functional groups take position number 2. Let's take another example. As you can notice here that double bond present in position number 1. And then it changes its position to be in number 2. Hence, directly we will know this structural isomerism is a positional. Next type of structural isomerism is functional isomerism. This means a compound that have same molecular formula but different functional groups. Let's understand the meaning first. This means that there are two functional group isomers, which are alcohol and ether, as well as aldehyde and ketone. As we know that alcohol and ether both are having the same molecular formula, which is CnH2n plus 2O. But we know that the functional groups are different, and also nomenclature of organic compound is different. But only the molecular formula they have in common. While aldehyde and ketone both are having the same molecular formula, which is CnH2nO, but the functional groups are different. Let's take this example, which is ethanol and dimethyl ether. First compound have alcohol group. However, the second one have ether. Both have the same molecular formula, which is C2H6O, but different functional groups. On the other hand, example of aldehyde and ketone is propanone and propanediol. Each compound have different functional groups but same molecular formula, which is C3H6O. The last type of structural isomerism is metamerism. Metamerism is unequal distribution of carbon atom on either side of functional group. And remember that metamerism displayed by compounds with non-terminal functional groups. Examples of non-terminal functional groups are ether, ketone, and ester. Now let's take example of these metamerism. Methylpropyl ether and diethyl ether. In methyl-propyl ether, the functional group located between two alkyl groups which are methyl and propyl. So, directly we'll say this functional group is non-terminal. So, it can show metamerism. Let's count number of carbon atoms on both sides of ether. On the left side of ether there is 1 carbon atom. But on the right side there are 3 carbon atoms. However, in diethyl ether, there are 2 carbon atoms on both sides of functional group. Hence, these compounds show metamerism. Actually, that the metamerism means unequal distribution of alkyl groups on either side of non-terminal functional group.